the different operations that are to be performed or that is performed by the processor by using a single bus organization. There are a number of operations which are categorized into 4 as shown in the slide. The first category is a register transfer operation. Register transfer operation means that to transfer a data from one register to the another register inside the processor itself, or transferring the data or anything or any instruction between from registers to the ALU, from ALU to the registers. This is nothing, whatever happens inside the processor from registers to registers is nothing but a register transfer operation. The second operation is the but obvious. The main job of the CPU of the processor is to perform the arithmetic and logical operations, which is nothing but the second category. The third category is fetching the contents. The contents can be data or instruction from a memory location and load it into the processor. That is nothing but taking something from the memory and putting it into the processor. The third one is the opposite of, the fourth one is the opposite of the third one. That is storing a word of data from a processor register into a memory location. That is, you are going to take something from the processor and put it into the memory. This is nothing but storing. Fetching is nothing but taking something from the memory and putting it into the processor. So these are the 4 categories of which different operations are performed by the CPU or by the processor by using a single bus organization. Till over here, if the question is asked for the single bus organization of a data path inside a processor, you have to explain till over here. Okay, starting from the slide which shows the organization diagram till this slide. This is register transfer instructions, register transfer operations. Every register, it is not directly connected to the internal processor bus. It is connected via 2 switches. Okay, these switches facilitates whether to input the data into the register or whether to take the data out from a register. So these switches have some similar names. Suppose RI is a register. Okay, so there are 2 switches, RI in and RI out. Okay, as we know, the switch either it is on, either it is off. Okay, in bit format, whenever we want to say something is on, we supply 1 to that. Okay, means it is holding the value as 1. If we say it is off, okay, it is nothing but supplying a value of 0 or holding a value of 0. Okay, suppose I want to put something into the register RI, which is coming on the internal bus. Okay, so I will supply RI in equals to 1 and RI out equals to 0. So what will happen? Whatever the contents of the processor bus is there, it will go inside the register and it will stay inside the register RI. If I want to read something from the register RI, I will supply RI out equals to 1 and RI in equals to 0. What it will do, it will on the switch RI out and it will off the switch RI in. So whatever the contents are there of RI, it will be read through the switch and it will be given to the processor bus. Okay, this processor bus will take it to that data to the specific destination. Okay, this is nothing but a register transfer operation. Yes, now we have seen this example how if you want to read and write. Yes, if you want to take data or contents or read the contents of the register R1, so R1 out equals to 1, and if you want to input some contents into the register R4, you are going to give R4 in equals to 1. Okay, this is nothing but move R1 comma R4. Okay, the second category of operation that is being performed by the processor by using a single bus organization is arithmetic and logical operations. Whenever we say arithmetic and logical operation, the first thing comes to our mind is the ALU. Yes, the ALU performs this arithmetic and logical operation. But we should understand that the ALU performs these operations, but it does not have any internal storage facility. So whatever the storage of the operand, storage of the result is to be done is outside the ALU. Okay? So the register Y holds one of the operand, and the other operand is made available via the internal processor bus at the point B. Okay? So one of the operand will be put into the register Y. From register Y it will go to the mux. The mux will be supplied as the select Y signal. So automatically whatever the contents of the Y are there, it will be given at the point A. Okay? This is nothing but the first operand has reached ALU. The second operand is taken directly via the internal processor bus and is given at point B. So the ALU will be performing the specified operation, arithmetic, any arithmetic and logical operation on the operand A, on the operand B, and the result will be calculated and it will be stored in the register Z. Okay? This register Z will be storing this result or storing the output in the temporary basis. After some time, processor automatically shifts this contents to the specified destination. So as you can see, the register Y, how it is connected to the internal processor bus? It is not connected directly. It is connected via a switch which is called as Y in. Okay, Y in, if you want to put something into the register Y, Y in is equals to 1. Okay, the Z register. Z register is connected to the ALU via a switch Z in. If ALU wants to put the result into the register Z, Z in will be equals to 1. If the contents or the result that is stored in the register Z is to be shifted to a specified destination via the processor bus, the Z out switch will be supplied as 1. Okay? Once you supply Z out equals to 1, the contents of the register Z will be supplied to the processor bus. From the processor bus, it goes to the specified destination, which can be a memory location or which can be the other internal registers. Okay. To understand the performance of arithmetic and logical operations, we'll take an example where the contents of the register R1 are added with the contents of the register R2 and the result is stored in the R3. To perform this operation, the sequence of operations that takes place, okay, by using the in and out switches of respective registers is shown in the 3 steps. Okay, these 3 steps are called as sequence of operations. So first thing, you want to add the contents of R1. So first you have to take something out of R1, right? So R1 out is being supplied as 1. You are using this R1 out in the first step. It is nothing but supplying 1 to that. If you are supplying a 0, you are not going to include in the steps. So in the steps, if you see R1 out is included, it means that R1 out equals to 1. So equals to 1 is not written over here. Okay, it is understand that if it is written R1 out equals to 1. Oh, another thing, Y in is also written. What it indicates? Whatever the contents that we have taken out of R1 will be put into the Y register by supplying Y in equals to 1. So in the first step, R1 out and Y in are the control signals or control switches that are being used. In the second step, the second operand is to be taken out from the register R2. So the register R2 out is used. The addition control signal will be supplied to the ALU. Okay, so automatically the contents of the R2 which are taken out are going at the point B. Okay, so it is not written because it is understandable that whatever you take from a register, it is going on the processor bus. From the processor bus, it will automatically go to the ALU, to the ALU the add control signal will be supplied. So the ALU understands that yes, what has come at point A is to be added with the operand that has come at point B. Okay, what Zin indicates? Zin indicates that after the addition is performed, the ALU will put the result in the Z register by supplying Zin equals to 1. So it is written as Zin. What the third step says or indicates? The result should not be stored in the Z register permanently. As we know, the Y, Z and temp, they are used for temporary storage. Where the content should go according to the instruction says that R1 plus R2, the result should be in R3. Where is the result after the second step? After the second step, the result is in the Z register, which should be taken out and put in the register R3. So the Z out signal is activated, that is Z out equals to 1. So automatically the result that was stored in the Z register, it will be taken out. It will be put on the internal processor bus. From the internal processor bus, it will go to the register R3. Why register R3? Because R3 in is being activated, okay, by supplying 1 to that. So in this way, by using these 3 steps, the R1 plus R2 instruction is executed and the result is being stored in the R3 register.